Today's lesson 4E review of length notes. Now the first part up here, it's just conversions. You do need to know how to convert, say, from length to area to volume units. Length is pretty straightforward. Let's see if you remember. To go from kilometers to meters, so if I had 1 kilometer, how many meters is that, Samuel?
1,000.
1,000. So if I had 1 kilometer, it's 1,000, and the reason why you get 1,000?
Wrong way around, so you got to divide on so 1 meter divided by 1,000 is 1 kilometer.
No, it is. So if you had 1,000 meters to make it in a kilometer, how do you go, like how many kilometers are there? There's 1. So to go from 1,000 to 1, what do you have to do? Yeah, and that's where it's counterintuitive. So what you just said there is that's why I drew the arrows for you. It's very counterintuitive because we feel like going from meters to kilometers, you got to times by 1,000. But remember, kilometers is much bigger than meters. So that's why you need less of kilometers in terms of value, but more in meters. Okay, so one way to remember it is just pick a number that you're going to remember, like 1,000 meters equals a kilometer. So how do you go from meters to kilometers? And the logic is you'd have to divide by 1,000. And that's how you get the arrows correct. But if you don't think about it before you do it, that's why most students get them wrong. That's why I like to give out the chart to begin with. But that's a good point. So yes, meters to kilometers actually divide 1,000, and therefore kilometers to meters. So if you had 2 kilometers, we know that that's 2,000 meters, but how do you go from that to that? Well, 2 to 2,000, you have to times it by 1,000. So here should be times 1,000. And then from meters to centimeters, I wrote here times 100. So that means from centimeters to meters, you should be divide by 100. And then similarly, if this is divide by 10 from millimeters to centimeters, well then 1 centimeter is equivalent to 10 millimeters. So it's times 10 on the top. Okay, so just fill that in just in case you might make a unit conversion mistake. What's another thing you need to memorize when it comes to lengths? Well, there's perimeter, which by this point you would all know what a perimeter is. But another one is perimeter of a circle, which is known as what? What's the name for a perimeter of a circle, Andrea? Circumference. What's the formula for circumference? Hands up if you know. Yes, Joanne. Good. 2 times pi times the radius gives you the circumference, but it can also be written as what? What's another formula? So you got 2 pi r and pi d. Pi times the diameter. So we can see that twice the radius is the diameter, so that's why you got 2 versions there. Okay? Circumference tells you the perimeter of a circle, whereas the area tells you how much space the circle occupies, or the size of that circle. So the area of a circle is equal to what? Can I please have Nishi? Pi times radius squared. Very good. Remember, radius squared is not radius times 2. Radius squared is actually radius times radius. Next property. Out of curiosity, do you know the formula for the perimeter of a sector? This is called a sector, which is like a partial circle. What is the formula for a partial circle? Hands up if you know. Raph.
Theta over 360 times squared.
Beautiful. Oh, actually, that's the area, not the perimeter. That is the area, which is correct because pi r squared gives you the area, but theta over 360 tells me how much of the circle do you want. So if they gave you only 320, then you know it's 320 degrees out of the 360. So hence that tells you the proportion that you want. But what's the perimeter of a sector? So perimeter, clearly you have to run this distance on the outside, and then this distance. Anyone know? Yes, Violet. Theta? Beautiful. This will give you the partial distance around the circle, just like your area formula. If 2 pi r is the circumference, this is the proportion of circumference. And very good. And this is the one that most students miss out on. So I had a year 9 mainstream student who came to me, and I gave them a problem where there was a partial circle that was like this. Where it was like this. But it did not include that. Okay, so it was like this. That was the running track. And the student used the formulas all correct. They were able to find the distance from here to here, distance from here to here. But then the mistake was they used this formula where they added on 2r. You got to know that in the formula, 2r is if you do include the radius. In this particular problem I just gave to you, this does not include the radius. The perimeter of the shape will be outside curve plus these lengths here. It doesn't include the radius. So the student, when they use the formula, they're not thinking, well, what's that 2r represent? You only add on the 2r if you have the radius. In this particular case, no. So be mindful as you're copying these formulas, just be careful. This is the curve. So write for yourself so you know this is the curve. And then this is the 2 radius length, or radii lengths. If the problem doesn't have the radius, you don't include it. If it's a curve, you only take the curve. Most problems do have the radius, but in the application ones, the composite shapes, be careful with that formula. It's a common one that most students make a mistake on. Okay? So one's a radius. If you have a radius, this one's the curve. All right. So those are your notes. That's reviewing the length notes that you have from pretty much year 7 to year 9 mainstream. Let's do an example. Here we go. Consider the given 2-dimensional shape. This is a 4-dimensional shape or 4-sided shape. Find x when the perimeter is 21.3 meters. So we go. We know the perimeter is the outside distance. So I need to add 4.9 by x by 3.2 by 5.1 to find the perimeter. So I write it out. 4.9 plus x plus, so from there, x plus 3.2 and then plus 5.1, we know that the perimeter is meant to total 21.3. Note in this exercise or from here, you are allowed to use a calculator. Okay, especially when it comes to area of circumference measurements, we use a calculator. Unless you want to add this, so you can add them. 49 plus 32 plus 51, let's work that out. That's 12, 1, 5, 5, 10, 13. So what, 13.2? So 13.2 plus x. How do you find x? What do you do next? Sean. Beautiful. That's positive 13.2. So take 13.2 on both sides. 13.2 take away 13.2 should be 0. So you got x left over. X will be equivalent to 21.3. Take away 13.2. You can treat it as 213, take away 132 if you like. That's 1. 11 take away 3 is 8. So you expect about 8.1. So far, so good? All right. Next example. Flip over to the next page. All right, now we're going to do some circles. If a circle has radius r centimeters, find the following, rounding the answer to 2 decimal places where necessary. The circumference of a circle when r is 3.5. What would you do here? Can I please have, let's go with Mira. Example 2, you got a circle? They tell you when radius is 3.5. How do I find the circumference? What would you do? 2 pi r. My r is 3.5, so you should do 2 pi times 3.5. The exact value is double of 3.5 is 7, so you can write a 7 pi, but since they asked us to round to 2 decimal places where necessary, in this case, I can round 7 pi by typing on my calculator. So here we go. If you got a calculator, let's see if you can round. Sometimes students don't know how to round, so let's check. 7 pi. Let's see what you guys get. 7 times pi. All right. What is this answer rounded to 2 decimal places? Can I please have, let's go Sage.
What does it say?
I'll zoom in. Is that bigger enough?
Yeah.
All right. Round that to 2 decimal places. What would the answer be?
21.99.
Beautiful. So we take 2 decimal places. 99, but then check the third digit. If it's 5 or more, you round it up. So if it was 5, then you would have rounded all to 22.00, but in this case, it's still 21.99. So you can write here 21.99. Don't leave your answer without units. What's my units? Good. If it's area, make sure to put these squared units in there too. A rule for R in terms of circumference, C. What is it trying to say? What are we doing? Hands up. What does it mean by finding a rule in terms of circumference, C, Joanne?
Find R using circumference.
Yeah, it means that your formula C is equal to 2 pi R. They want you to rearrange this equation so that you get a formula or the rule for R. So let's zoom in a bit. I want to find R, this one. I don't need that 2 pi on the right-hand side. So what do? How do I get rid of that 2 pi on the right-hand side? What would you do? Hands up if you know. How do I get rid of that 2 pi? Raha. Very good. When you write 2 pi r, it means 2 times pi times r. So if you want to get rid of it, do the opposite of times. So in this case, divide the rights by 2 pi. Whatever you do to one side, you do to the other. 2 divided by 2 cancels out to be 1. And pi divided by pi cancels out to be 1. Remember how I taught you can only simplify the way I just did if it's times in between. If it's addition or subtraction, you can't do what I just did. But it's times, so it's okay. So hence, now you have r on the right-hand side is equivalent to circumference divided by 2 pi. This is your rule to find the radius. Okay, so if you know the circumference, divided by 2 pi, and you will get your radius. Last part of the answer. C, the radius of a circle with a circumference of 12. Since we've got the rule now, r is equal to, since they said circumference is 12, 12 divided by 2 pi. That should give me the radius. So here we go. Use your calculator. 12 divided by 2 pi. And that gives you, rounding this to 2 decimal places, what does this give me? Can I please have Sanvi? Two decimal places. Okay, so normally you take 2 decimal places and 90, but you always check the third digit. If it's 5 or more, good. Then you round that last digit up by 1. So the answer is not 1.909. What is it again? It was 8593. 8593. The answer is rounded to 2 decimal places, keeping the first 2 digits, but check the next one. If it's 5 or more, you got to round up the last digit. In this case, it is the 9, so hence it's 1.91. You don't finish there. What are you missing? Or what am I missing? Good. Units. Okay, make sure to put the units in. So if we do a test, I'll be checking. If you don't have your units, I will be penalizing you as well. Okay? There we go. That's example 2. And on to our last example. And then I'll leave the 4E reasoning. See if you can figure that out yourself. I'll write the solutions afterwards, but I want you to check it. But I'll do example 3 with you. Example 3. This sector, which means partial circle, has a radius of 5 centimeters. So here's my radius. Find the perimeter of the sector shown. Leave answer in exact value. Don't change it to decimals. Here we go. We want to find the perimeter. Now, this is a partial circle, and I gave you the formula before. What is the formula for a partial circle? Can I please have Andrea? Ooh, that's for the area, partial circle of an area. Area of a partial circle, so it's not pi r squared, it's
2 pi r times theta over 360 plus 2r.
very good. And remember that 2r is only if you have the radius, and in this shape, yes, we do. So the curved part, that's calculated by the first bit. The second part are the two radii that you can see. So be careful with your diagrams. Think about the formula. In this case, we can use the formula in its full entirety. So here we go. All we need is a radius, and they already got us a radius of 5. So all you have to do now is plug them in. 280 degrees is the partial circle, so it's 280 out of 360 times by 2 times pi times 5 plus 2 times 5. Remember, you want to leave your answer in exact values. Let's simplify where we can. What's 280 over 360 in simplest form? Anyone know? 7 over 9, yes. Divide by 40, very good. So yes, this is 7 over 9 times 2 pi times 5 is 10 pi plus 2 times 5 is 10. If you multiply these fractions, what's 7 over 9 times 10 pi? What's that simplified to? First bit, hands up. Yes, Joanne.
70 pi over 9.
Beautiful. If you're not sure, you can change it to a fraction. So 10 pi on 1, top with top, bottom with bottom. So 7 times 10 gives me 70 pi on the numerator, and 9 times 1 gives me 9 in the denominator, plus 10. Now, up until this point in year 12, it is expected that you don't leave your answer with 2 terms. Year 9, I can sort of forgive you and just let it be. At year 12, they consider simplifying means you make it 1 term. This is considered 2 terms, so they usually combine it together. Okay, so out of habit, it's probably worthwhile learning to combine only in your final answer. Okay, in your final answer, simplify everything into 1 nice term. So here, how do I combine 70 pi on 9 plus 10? How do I do that? Anyone have a clue? Raha?
Get 10 of the same denominator.
Good. This is 10 over 1. Remember, you can only add fractions with the same denominator because then that's the same type of fraction. So 10 over 1 is not the same. To make it the same, I need to times both top and bottom by 9. That now gives me 70 pi on 9 plus 90 on 9. And we can combine that together as 70 pi plus 90 all over 9. This is the preferred answer at year 12. That you combine them all together, but I'm still missing something. Very good. A lot of students will miss out on that bit just because it looks nasty. Okay, you will get answers where it will be fractions or have a pi, and it can also have a radical sign, so surd, and that's still okay, but you can't forget about your units. So that's an exact value. If they ask for decimals, you give decimals. In this case, they want exact. All right, team, that's pretty much the example of exercise 4E. 4E is just review of lengths. The last one there, it's a reasoning question. I'm curious how many of you know or figure out the problem to solving this one. So you got a square of side length x. Here's your square, x, 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 and x. They all fit just inside a circle. So that means the corners touch the ends. Find the exact circumference of the circle in terms of x. Have a go if you like. I'll write the solutions later. Okay? But that's it for today. That's exercise 4E. Next lesson will be Pythagoras theorem in 3D shapes. Okay?